In this question, we have a restaurant manager wanna double check that the waiting time is 3.8 minutes, right? So in this purpose, he randomly selected 81 order samples, and from those times, he calculated the sample mean, so 3.59, and as well the sample standard deviation was calculated from the 81 sample, which was 0.9. So now, just to put names on them, this is the S, it's gonna be 0.9. This is the X bar, it's gonna be 3.59. And this statement over here, all right, this is your 80, which is the mean equals to 3.8, and that's the claim, right? That's what we want to verify. So now let me put it on the side, all the information we have. X bar is going to be 3.59, the S is going to be 0.9, the N is going to be 81, the mean, which is 3.8, and as well we have the alpha over here, so we can put it on the side, which is 0.01. Now for the first question, because we have 80 is the mean equals to 3.8, then H1 would be the negation of that, and that will be the mean different than 3.8. So from H1 we can tell this is a two-tailed distribution. All right, now the fact that we are getting the S, right, so this is gonna imply, so because I'm having the S equals to 0.9, this is gonna imply that sigma is unknown for us. And if sigma is unknown for us, what we're gonna use, the T table instead of the Z distribution. All right, so we know we are using the T values. Okay, so the first part is already answered. Now what I'm going to do is I'm going to follow the steps of testing, hypothesis testing, and then I go back and input the variables, right? So now this method is the traditional method. You're going to compare the T stat versus the T critical, all right, and then we can make a decision about that. Now because we know the alpha, so the first step is done, right? We stated the hypothesis claim, so this is step 1. Now step 2, which is the critical value. So the critical value is always coming from the alpha. We have the alpha and we know it's two tails, so we know this is half of the alpha here, and the other half can be right here. All right, and the value that you're gonna get here is gonna be the T critical, and that basically the cutoff over here, right? So that's where we're gonna stop, and any value in between you do not reject 80. Otherwise, if you are outside, either from the right or the left, you reject 80 and reject 80. Okay, so let's start with step 2. So for step 2, what we need the N, obviously, and the N is going to be 81. So degree of freedom, it should be 80. Now we know we are using two tails. So if I'm using two tails, the alpha for two tails is going to be 0.10, no, 0.01, can be 0.01. Now that is only for two tails, so one tail of it will be equals to alpha over 2, and that's going to be 0.005, right? So now I can use my table. It's a t table, and this should give me t critical. So here on the table we have two tails, which is 0.01, and that's the value here, and we can see one tail only going to be 0.05. so we are using this column, and we have to go all the way to 80. So 80 is here, and I think this is the value, right? 2.639. so the t critical is going to be plus or minus 2.639, right? And there are two values because tails, right? So let's put it down. This is going to be a negative 2.639. This is going to be positive 2.639, and they are symmetrical. Okay, once we get the critical value, we can go to step 3, which is calculating the test value, right? So step 3 is stat, and this should be equals to x bar minus the mean divided by s divided by radical n. So the x bar is 359, the mean is 3.8, the s is 0.9, and 81 the n. So this is going to be 3.59 minus 3.8 divided by 0.9 divided by radical 81. Okay, double check again. Now we can use the calculator. All right, again, open a parenthesis, 3.59 minus 3.8, close the parenthesis, divide by, open a parenthesis again, 0.9 divided by square root, second and squares, and 81 here. Exit, close the parenthesis. So we get minus 2.1. Okay, so let's go and place it on the chart. So we notice here that t stat is going to be minus 2.1, and that's going to be smaller than minus 2.639, which is within the do not reject zone, right? So that's going to be our decision. Do not reject 80. Step 5. Because we did not reject, we do not have enough evidence. So basically we look for the evidence, and the evidence are not strong enough to reject it, right? And the final decision is gonna, you had two choices, either H0 or either H1, and we agree with H0, right? We couldn't find enough evidence to reject it, so we gonna keep it. So you're gonna keep H0, which is the assumption the mean is gonna be equals to 3.8, and that's all. All right, now let's try to put all the information we found into the question. So here you're gonna be H0 is equal, this one is different, 3.8 here. Okay, let's check it. Next, we want the test statistics. So the test statistic is minus 2.1, negative 2.1. Check it. Okay, the p-value. Okay, so the p-value here, we can read it through the table. However, I don't know if you're going to be precise. So minus 2.1. So remember, you are in degree of freedom 80 and you have 2.1. So 2.1 is going to be between these two values, this one and this one, right? So you're in between these two here. Now the problem is this table is not precise enough. So you know you are between this p-value and this p-value. However, the book or the exercise, they want the exact value. So what we're gonna do, we're gonna have to use the calculator, right? So let's try to do the calculator correctly, right? So in order to get the p-value with the calculator, I could use the statistics. All right, so if I go to stat, I go to test, and then I'm gonna choose number 2 because I'm using t-stats. I'm using t-test, sorry. So I'm gonna do this, and of course you have data and you have stats. You're gonna go with stats, and then you're gonna put the value of mu0, and that's gonna be 3.8, and then you could go to x bar, which is 3.59, and then you can go to the s value, which is 0.9, and then you can put the n, which is 81, and then you have to state the hypothesizing, which is 2 tails, so different than mu0. Different than mu0 means different than 3.8. Enter, and then calculate. So this calculator here will give you the exact p-value, and that's going to be 0.0388. Let's put it down, and it's giving you 2 tails, by the way, right? So it's going to be 0.038, and they want 3 decimal places, so 9 here. Okay, let's check it. Good. All right, so here state the conclusion, and according to our work we say we do not reject, and there is or there is not, there is not, there is insufficient, not evidence. And okay, for the last part, we shouldn't be concerned about the shape of distribution, because according to central limit theorem is saying that if n is greater or equal than 30, then the t distribution should be almost normal, and that is the case because n equals to 81. So we should choose no as an answer, and there is an exemption here, so unless the population is skewed, all right, which is not the case, but anyway, so this is gonna be D as the final answer.